Hello and welcome to my video demonstrating UART serial communication between two microcontrollers. I have microcontroller A here acting as our sensor node for our potentiometer and microcontroller B acting as our output node for our LEDs. These two microcontrollers are communicating via our TX and RX pin, with TX being on our input node and RX on our output node. Our potentiometer is connected to our power of our sensor node, it's receiving 3.3 volts and connected to ground, and it is designated under our A0 analog pin. For our LED outputs, all three are connected to their own output pin, with red being LED 1, green LED 2, and blue being LED 3 in the order of D4, 5, and 6. So the LEDs receive power from these pins and are connected to ground with a resistor before. So the idea is that our sensor node is going to receive a raw value from our potentiometer, and it's going to communicate that over to our output node. Once our output node receives that information, it'll then change the behavior of our outputs based on the percentage that was sent from our input side. So let's go ahead and get into a little bit of the code so I can further explain. So for the code for our input node, I have a couple of variables here. Pot pin would be our potentiometer, and we're just designating it to our A0 pin for our analog. Our next one is last send time, which basically this variable just stores the last time the sensor node sent a message, and it's used with the milliseconds. It's used every 500 milliseconds, which is our send interval variable. And that basically, instead of sending a message nonstop, this variable here helps us clean up our serial monitor so that we can see messages every half second. Here in our void setup function, we have our serial begin, which basically allows us to monitor what's happening on our input side. And then we have serial one.begin, which basically establishes and allows the communication between the two boards. On our loop function, our on our loop function, it basically checks the last time a message was sent, and if that time was greater than our send interval of 500 milliseconds, then it goes ahead and saves the current time, and it reads that value coming from our potentiometer, and then it converts it into a percentage with our level variable. Our serial.print is basically telling the system to print out what level our potentiometer is operating at, and our serial one.print is then sent over to the output side for it to read. So our programming for our output side, like I said before, it's going to be receiving those messages from our input node, and it's going to be changing the behavior of our outputs based on that information. So on our output side, I have a couple of variables listed here, LED 1, and designating those pins for them. And then we have a couple of communication variables as well. with last message time being the last time a valid message was received. Communication timeout is for is to simulate like if you have a bad wiring or basically like a unplugged, basically a loss in communication that occurs if our system doesn't receive a message within 2 seconds, 2,000 milliseconds. Same here with our void setup. We have the same serial monitor baud rate for serial begin and serial one.begin for communication. And we are designating our outputs for our LED variables. Turning all LEDs off at startup, and moving on to our loop of the actual program of what the outputs are doing. We are receiving those UART messages from our input side, and we're checking if communication fault has occurred with these functions. So receive UART message is basically are we receiving a message from our input node and incoming characters from that side. So demonstrating what our programming actually does for our board, I'll go ahead and plug in our second board so we can see power. So as you can see, our LED values for our potentiometer are here in our control LED function. If the level is between 0 and 25%, then only LED 1 would be on. 26 to 50% would be LED 2. 51 through 75 would be LED 3. And anything above that, all LEDs would be blinking. So I'll go ahead and demonstrate. We can see on our serial monitor here that we are communicating. As we turn it up, both monitors change values. And as we break 25%, should move to our second LED. And we'll continue to go up. 75%. Oh, sorry. Oh, that's right. 50 to 75% would be our LED 3, and then anything above that would flash all of them. Going down the rest of the code, I have check communication fault function, which basically checks for that timeout. If it didn't receive a message within that 2 seconds, it would then send out a message for our monitor to say communication lost. And I'll go ahead and demonstrate that now. I'll just unplug our wiring here. Sorry. 2 seconds to pass. Oops, right there. And you can see our message has popped up. Communication lost. Plugging it back in. Yep. Thank you for watching.